Good day, everyone. We are Group 3, and we welcome you to the world of metrology and blueprint reading, the heart of engineering and manufacturing. For today's discussion, we will be focusing on the two main topics of metrology, blueprint reading. In the wholeness of this report, we will be exploring the different principles, practices, terminologies related to each topic. To start, let us first delve into the world of measurements in metrology. To share more about this discipline, here is Crystal EBORA.
Thank you, Carlos. The term metrology is derived from the Greek word metro and logi, which means measurement and science. So basically, it is the science of measurement. This discipline can be seen in our daily lives and has changed society ever since. So think of metrology like a captain of a ship that has helped create lots of cool inventions and important scientific discoveries in our modern world. It plays a pivotal role in ensuring products meet standards and is applied in various technical fields. Now, in line with metrology, let's explore the difference between precision and accuracy. These two terminologies are always associated with one another, but what are their differences? In metrology, accuracy refers to how close a measured value is to the actual or what we call the true value. On the other hand, precision relates to the consistency and repeatability of measurements, showing how close the measured values are to each other. So, just like as shown in the diagram, in hitting the target, as you can see, the high accuracy shows how the shots were near the bullseye, while high precision shows how consistent the shots were to each other. Now, going forward, let's discuss the different elements of the measurement system. To easily memorize these elements, just remember the acronym SWIPE. Basically, it stands for Standard, Workpiece, Instrument, Person, and Environment. First is standards, which point out the physical quantity to which quantitative comparison is made. Second is the workpiece, which is the part of the feature of the workpiece that needs to be measured. Next is the person. This relates to the ability of the person that is measuring. And lastly is environment, which points out to the conditions to where the measurement is done. Now, let's move on to the two main kinds of measurement. So we have Mr. Carlos to tell us more.
I'm back. Now, let's talk about the two kinds of measurement. There are two kinds of measurement, linear and angular measurement. Linear measurement is about measuring straight distances using tools like rulers and tape measures. Angular measurement, on the other hand, is about measuring angles between lines or planes that meet at a point, often using degrees. Linear measurement is common in everyday tasks like measuring length, while angular measurement is used in specialized areas where accurate angle matter, like engineering and machinery alignment. Now, we know the difference between angular and linear measurement. Let's see their tools. First are surface plates. These tools is mainly seen on machine shops. They are flat, level surfaces used for measuring and inspecting the level and dimensions of objects. They are typically made of granite or cast iron and placed on a stable surface. Second are steel rulers. These straight edges are precise measuring tools made of stainless steel that come in various lengths and are used to measure distances. Next are vernier calipers. These precise instruments measure length, width, and thickness. Set to 0, choose measurement mode, and measure between the jaws and precise for precise readings. Up next are micrometers, also known as micrometer screw gauges. They are precision measuring instruments used for very precise linear measurements, often to the nearest thousandths of a millimeter or 10,000ths of a centimeter. Next is height gauges. Height gauges, also known as height gauge calipers or vernier height gauges, are precise measuring instruments to accurately measure and adjust the height of an object. There's also a dial indicator, also known as dial gauges. It is used to measure small linear distances with high accuracy. They feature a graduated dial face, a needle-shaped pointer, and a spindle for measurement. And last of our linear measuring tools are gauge blocks. These blocks are measuring instruments used for calibrating and verifying the precision of other instruments. They are rectangular or square blocks made from high-grade steel or ceramic materials. Now, let us move on to the angular measuring tools. These tools are used to measure parts of an object at an angle. First are protractors, one of the basic measuring instruments used for measuring and drawing angles in geometrical and metrological applications. They come in various designs including flat, semicircular, and circular models. Second is vernier protractors. These tools are specialized measuring instruments used in metrological and engineering fields to measure and determine angles with high precision. They combine features of conventional protractors with vernier scale for finer grained angular measurements. The last two are sine bars and gauges. Sine bars are precision angle measurement instruments used to accurately measure and set angles. They consist of two cylindrical parallel bars, one of which features a V-groove on its upper surface, while gauges are instruments used to measure, check, and validate the size, accuracy, and quality of components or parts manufactured. They are essential for quality control and ensuring that products meet design specifications. Now, we have explored the different terminologies and instruments in metrology. Let us now apply this knowledge to our next topic, blueprint reading. Here is Darius DIMASACAT to discuss furthermore.
Thank you, Carlos. Now, what is blueprint reading? Blueprint reading is the ability to interpret technical drawings, often used in construction and engineering, containing vital information about size, materials, and other details of structures or products. Now, let us take a look at how lines convey meaning in a drawing, the types of lines and their language inside a blueprint. First is object lines. These lines are the main lines we look at in a drawing. It is thick and continuous lines that outlines the figure in the drawing and help define it. Next are hidden lines. These lines can be distinguished by their broken or dashed lines and used to represent features that are not visible in the current view but exist in the object or structure. Third is section lines. These lines are the hatch line we see in a drawing. It is usually diagonal along the figure and represent the material removed during a cutaway view or a section view. Now, we move on to center lines. This indicates the midpoint of a circular or cylindrical feature, marked with long and short dashes with an extended long dash at the center. Next is dimension lines. This display the size or distance of an object, with arrowheads at each end and measurements placed in between. Last, for this slide are extension lines. These are lines used with dimension lines. They mark the endpoints of a measurement, extending from the feature to the dimension line. Moving on, now let us know about leader lines. Leader lines are employed to direct attention to specific features or notes on a drawing, marked with an arrow or dot at one end and typically accompanied by a note or label. Next is the cutting plane. These lines indicate where an object is cut to reveal its internal structure, usually labeled with an arrowhead and an identifier like a letter or number for the specific section. And we also have break lines. These lines signify that a portion of an object is omitted to simplify the drawing, often represented by zigzag or wave lines. So there are three kinds of break lines used in drawings. They are used to remove or break out part of a drawing for clarity, and also to shorten objects which have the same shape throughout their length and may be too long to place on a drawing. Short and long break lines are used for flat surfaces. Cylindrical are used on rods, dowels, etc. Now, for the last two lines, we have phantom lines and border lines. Phantom lines represent alternate position or movements. They are drawn as long dashes alternating with pairs of short dashes, while border lines define the boundaries of a drawing sheet. They form the frame or border of the blueprint and may include information about the project, such as the title block. Now, let us discuss the second element in blueprint reading, which is the visualization. So, visualization essentially is the ability to analyze and understand technical drawings in a three-dimensional manner. It is one of the most important aspects of reading blueprints. Now, here are the different visualization and perspectives in blueprint reading. Perspectives are techniques used by architects in drawing to give the drawing a sense of space for the viewer. They show how the object will look in 3D space and are used where realism is required. Oblique drawings are a way to represent objects in a simplified three-dimensional form, showcasing their height, width, and depth to scale. This makes it easier to visualize the object's overall shape and proportions, and is generally drawn at 30 or 45 degree angles. Next, we move on to isometric projections. Essentially, isometric projection is a 3D drawing technique that makes objects look realistic by showing their length, width, and height, and is created at 30 degree angles. Now, in blueprint reading, we have single view and two view drawings. In a single view drawing, we see an object from just one direction. which makes it straightforward and suitable for simpler objects. On the other hand, a two-view drawing provides more detail by showing the object from two different angles. It's like having two pictures to give a more complete and accurate understanding of the object, making it useful for more complex things that need a detailed representation. Single view is simple while two view is more detailed and informative. Another type of projection is orthographic projection. This is like taking pictures of a 3D object from different angles, usually front, top, and side to make it one 2D drawing. This picture show all the details, sizes, and how the parts fit together. Each picture shows a different side of the object. So when we see on the figure using orthographic projection, it would be appear like this. Moving on, we also have different surfaces, namely hidden curved and inclined surfaces. Hidden surfaces in a blueprint are used to show things like internal walls, structural parts, pipes, or wires that are inside an object but can't be seen from the outside. While curved surfaces, on the other hand, are three-dimensional shapes or contours. They often found in objects or structures with round, curved, or irregular forms. These surfaces give a realistic and detailed view of shapes that aren't flat. Now, for inclined surfaces, these surfaces are surfaces at an angle. In representation, the degree of incline or the slope angle is often specified. In the figure, this is an example of a one inclined surfaces, while the second figure shows a two inclined surfaces. Now, that sums up the first half of our discussion in blueprint reading, where we discuss the type of lines and visualization in blueprint reading. Now, here is Clyde to discuss further about scaling.
Thank you, Darius. Now let's talk about scaling. So, what exactly is a scale? A scale is defined as the ratio of the drawing dimensions to the actual physical dimensions. It is often represented as a fraction or a ratio, such as 1 over 10, 1 is to 50, or 1 inch is equal to 10 feet. The first number represents the drawing dimension, and the second number represents the actual dimension in real life. In blueprint reading, scaling is about understanding how the sizes on the blueprint correspond to the actual sizes of the object or structure it represents. It ensures accurate dimensions. Some scales that are often used include full scale, half size, and quarter size. Full scale is literally 1:1 to the measurement of the drawing dimension, as it is the same as the actual dimension in real life. It is denoted by 1:1 scale. Next is half size, which means that the drawing dimensions are half the size of the actual dimensions. It is denoted by 1:2 scale. And last is quarter size, which means that the drawing dimensions are 1/4 the size of the actual dimensions. It is denoted by 1:4 scale. Now, let's talk about dimensioning. So, what is dimensioning? Dimensioning in blueprint reading is the process of specifying and conveying the precise measurements and dimensions of an object or structure, as represented in technical drawings and blueprints. Numerals in dimensioning use standardized English numbers and are usually written clearly and concisely in either architectural or engineering lettering in vertical form. Part of dimensioning is drawing dimension lines to indicate which part of the figure the dimension is referring to. The dimension line is typically divided near the middle to create a gap for the dimension numbers. These numbers are often placed above the dimension line, ensuring clarity and readability in the blueprint, as shown in the picture in this slide. Extension lines, on the other hand, are also employed in dimensioning. This helps the dimension to show the relationship of sizes from a line that is perpendicular to each other. Moving on, part of the dimensions are the arrowheads. These arrowheads are markers positioned at the ends of dimension lines in blueprints to indicate where the measurement starts and ends. They serve to clarify which features or points on an object are being measured. Properly placed arrowheads ensure accurate dimensioning, while incorrect arrowhead placement can lead to misinterpretation and inaccuracies. Lastly, dimensions are mostly assisted with notes to show what part of the figure is the dimension referring to. This allows the viewer to easily identify parts of the figure without overanalyzing it. Now, that sums up scaling and dimensioning in blueprint reading. Now let's move on to the final chapter for this topic, sectional views. Here is Cedrick to discuss more.
So thank you, Clyde. Now let's go deep into sectional views. So sectional views are simply the way we look at a drawing or the way it is drawn or shown in the sections of a figure. In the sectional view, cutting plane line is mostly employed to indicate where the cutting plane cuts the material. This is a heavy, short, long kind of line terminated with arrows. So as we can see here in the figure, the cutting plane line is placed in the middle of the figure to show where the figure will be cut in the future drawings. Next is the full section view. So the full section view is a cut along the cutting plane to reveal the internal details of the object. The section view shows one half of the object as a full view and the other half as a cross-sectional view. This type of section is commonly used when symmetry exists in the object. So as we can see here in the figure, the cutting plane line is placed in the middle of the figure as shown in the previous drawing. So the cut will be triggered in the middle of the object to show the internal structure of the figure. Next. So, a broken out section view is indeed a common technique used in technical drawings and engineering illustrations to represent fine internal details of an object when only a small portion of its interior needs to be highlighted. So, this method is especially helpful when a full sectional view of the object might obscure other important details or make the drawing too complex. In a broken out section view, a portion of the object is shown with a detailed, enlarged representation of the internal features, while the rest of the object is depicted as an outline or with less detail. The broken out section view typically includes a leader line pointing to the area of interest along with a label or note indicating that the detail is being magnified for clarity. This technique allows engineers, designers, and readers to focus on and understand specific internal features or components of an object without cluttering the drawing with unnecessary information. It's a valuable tool for conveying technical information effectively in engineering and design documentation. So next, we have a resolve section view. A resolve section view is a specialized type of sectional view used for objects with rotational symmetry. So this is mainly used for objects with a cylindrical shape or a circular shape in the manner of so we can rotate it. In this view, the cutting plane is not oriented in a straight line, but it is instead rotated around an axis to reveal the object's internal features in a circular or helical manner. This technique is particularly useful for objects like cylinders, cones, spheres, or other shapes with rotational symmetry, where a standard straight line section view might not effectively illustrate the internal features. By using a resolved section view, you can provide a more comprehensive and clear representation of the object's internal structure, especially when it follows a rotational pattern. It allows the viewer to see how the internal components or features are distributed throughout the object as if the object were sliced and unwrapped in a circular fashion, making it easier to understand the object's design and internal layout. Next, we have an offset section view is a valuable technique used in technical drawings and engineering illustrations when the standard sectional view isn't sufficient for highlighting specific internal features of an object. In this method, the cutting plane is intentionally shifted or offset from the object's center line or axis to draw attention to particular internal components or features. This approach is particularly useful when dealing with objects possessing complex interconnected internal structures that contain fine details. So, here are some points to consider when using offset sectional views. Detailed internal features. Offset sections are employed to bring to focus particular internal details that may not be readily visible in a standard section view. Next, complex internal structures. Objects with intricate and interconnected internal structures benefit significantly from offset section views. In such cases, presenting the entire cross-section could be overwhelming and less informative. Offset sections simplify the representation of complex interiors. Next is enhanced clarity. By shifting the cutting plane, an offset section provides a clearer and more detailed perspective of internal features without introducing unnecessary complexity. This approach enhances the understanding of an object's design and functionality. And that ends our discussion for metrology and blueprint reading We hope that you have some takeaways from our discussion. Again, our group greets you for reaching the end of this discussion. Again, we are Group 3. Thank you for listening.